given z is equal to f of y plus x plus g of y plus 2x, which contains two arbitrary constants. Okay, now how will you solve this kind of equation? Means we find required PDE by use of second order derivatives. Okay, so how will you find second order derivatives? First, if you want to find second order, we need to find first order derivatives. So this is nothing but P is equal to dou z by dou x, right? So which is nothing but, if you differentiate on both sides for this equation, okay, so here I can write from equation 1. Okay, so differentiate first function with respect to x. So I'll get f dash y plus x.
Sir, sir, that is
Yes,
two arbitrary constant or function.
this is two arbitrary functions. F and g is there. Okay,
Here,
previously I will show. Previously we are having only one arbitrary function. Okay, this one. Okay, similarly if you go for previous problem, this is also one arbitrary function. Similarly if you go with this, here also we are having arbitrary function f of ax minus by. Okay, next. In this problem, we don't find functions of x, y separately. So we have taken a and b are arbitrary constants. When you are taking arbitrary number of arbitrary constants, we will differentiate it for twice. But in case of arbitrary functions, we'll take use of first order derivatives, like dou z by dou x you can use. Similarly, dou z by dou y also you can use. Okay, so when they have given only one arbitrary function, we'll find PDE by the use of first order derivatives. That means dou z by dou x and dou z by dou y. Similarly, in this given problem now, they have given two arbitrary functions. Okay, when they have given two arbitrary functions means we need to make use of second order derivatives. Okay, if they are given only one arbitrary function means make use of first order derivative. That means dou z by dou x, dou z by dou y. But when they given two arbitrary functions, we have to make use of uh, all the derivatives which are available in the PDE. That means dou z by dou x you need to find, dou z by dou y you need to find. Similarly, dou square x by dou z square. Similarly, dou square z by dou y square. Similarly, dou square z by dou x dou y. All the differentiations we have to make use. Okay, so I'm finding first one.
So, sir, you have written arbitrary constant, sir. So, yeah.
Huh? Here, this one. Okay. This is arbitrary functions. This one you are asking. This is arbitrary function only. Fine. Now, g dash of y plus 2x and differentiate this one with respect to x. What happens? 2 into you'll get. So, you'll get 2 into g dash of y plus 2x. Similarly, q is equal to dou z by dou y. If you differentiate this function with respect to y, again you'll get f dash of y plus x into differentiation of y plus x with respect to y. It is 1 plus. Here also directly g dash of y plus 2x into differentiation of y plus 2x with respect to y. So x is constant, it will become 0. Differentiation of y is 1. Fine. Similarly, r. What do you mean by r here? Dou square z by dou x square. Second derivative of z with respect to x. So again differentiate this equation. What happens? Better I will take this equation as equation 2, this as equation 3. Here from equation 2, again differentiate this with respect to x. What happens? F double dash of y plus x plus already 2 is there. Again if you differentiate, you will get g double dash y plus 2x. Okay. So differentiation of y plus 2x again. Again you'll get 2, one more 2 is there. So you'll get 4. Fine. Similarly, yes. Dou square z by dou x dou y. Okay. So here dou square z by dou x dou y. How will you find? How will you find this? Dou square z by dou x dou y. This can be either written as, yes, shall I? Like this. Dou by dou x of dou z by dou y. Okay. So, yes is equal to dou by dou x of dou z by dou y. From equation 3 we will have. Okay. So, it is f dash of y plus x plus g dash of y plus 2x. Okay. Again differentiate with respect to x. What happens? S is equal to f double dash of y plus x into differentiation of y plus x with respect to x is 1 plus g double dash of y plus 2x and differentiation of y plus 2x with respect to x is 2. So I'll write this 2 here. Okay. So this is s value. Okay. I'm taking this equation as equation 4 and this as equation 5. Now t you will get. T is equal to what? Dou square z by dou y square. Okay. Dou square z by dou y square. So how much you get?
F double dash of y plus x plus g double dash of y plus 2x.
So f double dash of y plus x plus g double dash of y plus 2x. Okay, take this equation as equation 6. Okay, that means how we got this? From equation 3. Even this also you got it from equation 3. Okay. Now we have found all the derivatives. That means second order derivatives still. So now making use of all these equations, you can eliminate f and g. Okay. So observe this properly, whether you can eliminate this or not. Okay. Suppose if I take R, that means equation 4 minus equation 5. Okay. Equation 4 minus equation 5. What happens? Equation 4 minus equation 5. How much you'll get? R minus S is equal to
G double dash of y plus 2x.
yes, 2g double dash of y plus 2x, because f double dash get cancelled. 4g double dash minus 2g double dash, it is 2g double dash. Similarly, if you remove s minus t, okay, s minus t, that means equation 5 minus equation 6. Equation 5 minus equation 6. What happens? S minus t is equal to, how much you'll get?
G double dash of y plus 2x.
G double dash of y plus 2x. Now take this as equation 7 and take this as equation 8. Okay, from this, is it possible to eliminate g?
Yes, sir. 7 by 8.
So we have to divide 7 by 8. So equation 7 divided by equation 8, which is nothing but r minus s divided by s minus t is equal to 2g double dash of y plus 2x divided by g double dash of y plus 2x. So this g get cancelled. R minus s is equal to 2 into s minus t. Okay. So if you simplify this, what happens? R minus s. If you bring this to left hand side, minus 2s. Okay. So minus of this, so you'll get plus 2t is equal to 0. Okay. So r minus 3s plus 2t equal to 0. Or you can write this one as r. What do you mean by r? Dou square z by dou x square minus 3 into s. This is nothing but dou square z by dou x dou y plus 2 into t, dou square z by dou y square is equal to 0. Either you can write the solution as this much or this much. So in the final equation, we have completely eliminated f and g. So check this. Form the partial differential equation by eliminating arbitrary functions. For the equation z is equal to y into f of x plus x into phi of y. So this equation also very easy. So find out all the derivatives, second order derivatives still. So given z is equal to y f of x plus x phi of y. Okay, now what I'll do is I'll find first dou z by dou x. How much you'll get? Y
Y
into
into f dash of x.
yes, y into f dash of x plus x into, sorry,
phi of x. Phi of x, sir.
only phi of y. Okay, so differentiation of x is 1, so phi of function of y, it is constant. Similarly, dou z by dou y is how much? Differentiate z with respect to y. You'll get f of x, because differentiation of y is 1, f of x, function of x, you have to treat it as constant, plus x into phi dash of y. Fine. So now what we need to do, find, this is p, this is q. Now find r, dou square z by dou x square. So differentiate dou z by dou x again. What happens with respect to x? Y f double dash of x plus differentiation of phi of f, phi of y with respect to x.
0.
How much? So I'll get 0. Okay, next. Yes is nothing but dou square z by dou x dou y, which can be written as dou by dou x of dou f by dou y. Sorry, dou z by dou y. Dou by dou x of dou z by dou y, f of x plus x into phi of y, phi dash of y.
F dash of x plus q dash of y.
F dash of x plus phi dash of y. Correct. Differentiation of x is 1, phi dash of y is a function of y, it is constant. Next r, sorry, t. Dou square z by dou y square. So differentiate this equation with respect to y. So first term will be 0 plus x into phi double dash of y. Okay, so t is equal to dou square z by dou y square, which is nothing but x into phi double dash of y. Okay, so now observe all the equations. I need only from second order derivatives. I'll write this as equation 1, this equation as equation 2, and this equation as equation 3. Okay, so now what if you do? You can get eliminate of f and 1. Or you can take the numbering of equations from starting onwards. That is also no problem, because it will be good for you to represent. So this is equation 1, this is equation 2, this is equation 3, 4, this is 5, and this is 6. You can write. Now from equation 2, okay, from equation 2, you can write phi of y is equal to, sorry, from this I'm going to find f dash of x. Okay, f dash of x is equal to how much? P minus phi of y divided by y. Okay, since from equation 2. Okay. Similarly, if you take equation 3, okay, in equation 3, find out again phi dash of y. Phi dash of y is equal to how much? Q minus f of x divided by x. Okay. Now, if you substitute these two equations, that means this is from equation 3. Okay. Now, take this equation as 7 and this as 8. Okay. From equation 5. Okay. From equation 5 means yes. Okay. In yes, if you observe, f dash of x is there, phi dash of y is there. So these are the two values which are required. So I will substitute these two values in this. What happens? S is equal to, I have to add these two. P minus phi of y divided by y plus q minus f of x divided by x. Take LCM on both sides. What happens? S is equal to x into p minus phi of y plus y into q minus f of x divided by LCM is xy. Okay. So S is equal to px minus x into phi of y plus qy minus y into f of x divided by xy. So if you simplify this, S is equal to px plus qy minus, here I can take minus common, x phi of y plus y f of x divided by xy. S is equal to px plus qy minus, here x into phi of y plus y into phi of x. It is z. So from equation 1, it is z divided by xy. So since from equation 1. Okay. So finally you can multiply with this and finally you can write px plus qy minus z minus s into xy or xys, because I have sent this to this side and I have taken this s into xy to the right hand side. So all terms I am writing together, which is equal to 0. So finally we got the required equation in terms of PQRS. It is not P of x, it is P into x, Q into y, minus z minus xys is not this, you can write it as xys. Fine. Or you can write in this way also. Dou z by dou x into x, or you can write it as x into dou z by dou x plus y into dou z by dou y minus z minus xy dou square z by dou x dou y, which is equal to 0. Fine.